Okay, so today I'm going to be explaining Expert TA number 4 about the ice block. So the question states, a competitor in a winter sporting meet pulls a 48-kilogram cube of ice in the positive horizontal direction with a cable over his shoulders over a frozen lake. Assume the coefficients of static and kinetic friction are 0.1 and 0.03. And I'm going over part A, which asks to calculate the minimum force of F he must exert to get the cube sliding in newtons. So there's the cube right here, and then here's our angle. It's 25 degrees in the positive direction, and there's the guy pulling it. So first, you would want to draw a free body diagram just to get yourself set up for the problem to see which forces you're going to need to include in your equations. So for the free body diagram here, I have the dot in the middle is obviously the block of ice. Pointing up, we have normal force, and pointing down, we have the force of gravity. Our static friction is going against the way that he's pulling. So to the, well, looking down would be to the left here, and then to the right, and what they said is the positive direction is the force of him pulling, or the rope actually pulling on the brick of, or the block of ice. And I just showed that at the angle that was given, because we'll need that to figure out how much he needs to pull on it to actually make it move. So first, when you're calculating the minimum force, you are going to need to find normal force. The normal force is going to be equal to the mass times gravity, or times G, sorry, minus the force needed times the sine of theta. So I just plug that in. We're not actually going to fully solve the problem today. I'm just going to show you how to plug it in. So it's given in the problem that the ice block weighs 48 kilograms. So do that times 9.8 meters per second squared, which we know G is equal to, and then minus F sine of 25, because that was the theta given was 25 degrees. Then we need to find the horizontal part, or the horizontal, friction, because F of n is the vertical component, so F of x, we know that F of x is less than or equal to mu of the static times the normal force. So what we just solved up here would give us F of x equals mu of s times mg minus F sine of theta. I know I plugged in the numbers earlier, but when you go down, if you would actually do the algebra, this is what you would be left with, this equation right here. So you plug that in, and then we can also take that F of x can also be set equal to F cosine of theta. So we're going to have all like terms if we use that. So to put it all together, F cosine of theta equals mu of s, so the static friction, times mg minus F sine of theta. So that would be F cosine of 25, because again, the angle given was 25 degrees, times 0.1, which was given to us as the coefficient for the static friction, times 48 kilograms, the weight given, times 9.8 meters per second squared, which is G, minus F sine of 25 degrees. And when you solve for F, this will give you the value of the minimum force he will need to exert to get the cube sliding in newtons. Some pitfalls to watch out for. You need to make sure that you are showing the correct forces on your free body diagram. You need to make sure it's set up correctly and you have your forces going the right way, or else that could mess up where you put positives and negatives in your equations. You need your correct value for G. That's important in the equations that you use. It's a set value, so you just need to make sure you have that memorized. And then you need to make sure you're using the correct equations in algebra to plug everything in and to solve for the correct answer. So that was expert TA number 4 with the ice block, and that's how you would set it up to solve for the minimum force needed to get the block moving.